as Andrew said, my name is Robert Hodges. I run a data warehousing company. We host and support ClickHouse, which is a very popular real-time analytic database. So a lot of this talk comes from our work to understand how analytic databases can integrate with data lakes and how they can make data lakes better. This is something we're very actively working on. Yeah, I think that's enough marketing. One quick level setting question. How many people here, raise your hand if you know what a data lake is? Not bad, okay. How many of you have actually built them? Okay, good. So we've got a happy medium here. Great, let's dive in. So when I got my current job 6 years ago, running this company, supporting and hosting ClickHouse, the data sizes that we're getting were fairly small. So ClickHouse is a real-time data warehouse. It can read millions of rows per second into the database, hold billions or even trillions of rows in tables, and give you answers back on queries on that data within seconds or less. So when we first started, or when I first started back in 2019, we were typically seeing data volumes for people arriving as customers on the order of 100 gigs. I mean, not a huge amount of data. This is the kind of data that people might have in MySQL, for example, but they wanted answers really fast. What happened over the next few years was the data size grew dramatically. And in this graph, you can see some of the types of users that are interested in these real-time, or these use cases that are interesting for these real-time data warehouses, and they have culminated in observability, which is a huge driver of databases at this point. So for example, one customer that we have uses ClickHouse for LLM monitoring. They have 200 hefty servers which are reading something like 18 gigabytes of data a second. So the data volumes and the arrival rates have become huge. And this has basically created a big challenge for databases. It's really outside the design envelope of many of these systems. And in fact, if you look at data management in general, we see, particularly in open source, we still see that people have stacks which are largely disconnected silos. This is just a typical example of the kind of thing that we may see in our customers or users that we speak with. You might have ClickHouse reading from Kafka, processing, say, security data, like DNS requests, looking for people posting to malware, known malware hosts. You may have batch reporting using things like Presto with loading and transformation driven by Spark. And then you may have pandas talking to Snowflake, which is crunching sales data. The first two are open source. The database is out in the open source. Snowflake, of course, hides it behind their private APIs. So you have this kind of mishmash of databases disconnected with complex processes to move things in between them. And this rising flood of data has created a new way of trying to address the growing volumes of data and the need for different systems to see the same data and operate on it. That's fundamentally what data lakes do. So the idea is that rather than keeping things in block storage, where you might have to replicate it 3 or more times, you want to keep it in object storage, where it's vastly cheaper, on the order of anywhere from 10 to 20 times cheaper, perhaps even more. And then you have open file formats. And so the really transformative technology here was, of course, S3, the Amazon object storage, which is widely copied throughout the industry. Then open file formats. So file, designed for analytics, specifically things like Parquet or Orc. They have columnar structure to design for fast access on reads. And then what are called open table formats, which I'll dig into a little bit more in a minute, but two very popular ones are Iceberg and Delta Lake. And the idea behind having these centralized pools of data which have their own proper structure and management is all these applications can then feed off this data, and you can see these things like model training and batch queries just kind of grazing off this data and working on it and extracting information, cleaning it up, so on and so forth. Real-time analytics is still kind of not totally in this picture. That's something we'll talk about, but that is also coming. So what's actually happening under the covers with data lakes? What's the fundamental innovation? Well, the data lakes, modern data lakes, which were kind of defined by Databricks in a famous paper in 2021. They also they coined the term data lakehouse. What these data lakes do is they basically externalize database storage. So you can think of database storage as being a bit like your car. You have the engine, so the query engine. You have the transmission. Most of you don't spend much time worrying about how those things are connected together. It's a black box. So when you're driving the car, you just press the accelerator and, power goes to the wheels. Databases work like that. So they actually have storage underneath. It's completely hidden to you, and you talk through the query engine. But that storage takes care of things of defining what is a table, what are the files that are in that table, and where are they, all the way down to capabilities like being able to see the state of the table at different points in time. That ability is called time travel. And so what a data lake does is it basically makes that storage layer available in these, for example, using an open table format like Iceberg, so that the query engine can still look at it and serve its clients, but other applications can talk to it directly. So this is the fundamental innovation that has been happening over the last, this revolution began, I think about 2013. I think Netflix were the original people who had this problem in a big way, and they began to develop Iceberg, which is now quite popular today. So that's the technology, and this has evolved into, particularly when we look at something like Iceberg, into a very orderly organization where you will have the data, which is typically stored in Parquet. That's kind of the big winner at the moment in this race to find ways to represent data. There's metadata that tells where those files are located and makes them appear to be tables, so that if you want to go to a table foo, you can consult the metadata and find out all the files that make it up as of a given point in time. And then there's an emerging class of services called catalogs, which allow you to find the metadata instead of having to walk out to object storage and look for it by yourself. So these come together, and basically any application, like a data science application, as long as it has libraries that understand these three things, it can access the table. So it's as simple as that. And this is just an example of data science using PyIceberg, PyArrow, and Pandas. That's a typical way to do it, but it could also be Spark. It could also be an analytic database like the ones that we run. What's under the covers, if we go a little deeper, this complex set of files, you don't have to worry about the structure, because for the most part, the libraries, unless it's broken, you don't have to look at it. The libraries take care of it. But the interesting thing about it is that any program that can read object storage can see this data. So there's kind of an obvious issue about security here that pops up. There's some other ones about data getting possibly corrupted, so on and so forth. So this is basically sort of a basic overview of data lakes. Let's start looking at what this actually means, because that's the point of this talk. Well, first of all, I take it everybody here is operating open source at one level or another. You're making decisions about this kind of thing. Well, this opens up what could kindly be called a Pandora's box. I think there's another phrase, which is rat's nest. And it's happening for a couple of reasons. The technology is evolving quickly, and a bunch of people are developing projects. But the other thing is that the technology itself is not totally mature yet. So, for example, catalogs are relatively recent, for Iceberg, relatively recent. So there's these different choices you need to make, like what is the file format I'm going to use? Parquet looks like a winner right now. Not because it's the best necessarily, but it's basically the most popular. Iceberg, again, not necessarily the best, but it just happened to be adopted by a lot of people. The more people that use it, the easier it is to use. Catalogs, jury is still out about whether one will become dominant. Libraries that your applications can use, again, there are many of them that work at varying levels. Some are able to read data out of data lakes. Some are able to read and write. Some are able to do neither. They just corrupt data when you run them. So you have to be kind of looking at this stuff, following the technology, and making choices about which horse you're going to bet on. So this would be a problem, but fortunately, there's actually a kind of an interesting trend coming up, which is that the cloud vendors who are adept at finding new ways to sell storage, compute, and networking have seen the opportunity, and they are here to help. So they do this in a couple of ways. One is that the catalogs, which are becoming a linchpin to be able to find the data in the first place, those are now increasingly managed. Example, if you use Amazon, you may be using Glue already. And then there are many others shown here, and also additional ones that are being managed today. The other thing is the actual data lake storage itself is being managed. And there's a number of vendors who are doing this. I think the most interesting thing that has happened here in the last, say, 6 months is that Amazon has announced a new kind of S3 bucket, which actually implements the Iceberg format. And they do some very interesting things there. Among other things, they have optimized the performance so that this will perform well when you're doing the type of access that Iceberg typically does. So these are going to emerge, and as you're making decisions about building systems, it's important to watch these and to consider using them, because they're much easier than running it yourself. And they're actually, like the Amazon, the Oz table buckets are about 10% more expensive than regular S3, so they are not prohibitively expensive. Another emerging trend is that the real-time SQL databases, like the one that I work on, like DuckDB, like StarRox, like Apache Doris, they are now becoming very, very good are rapidly becoming good at reading out of data lakes very quickly, which is great because most application developers who deal with data know how to use SQL. The idea of being able to make a SQL connection, just to a database server and then see any local data plus the data lake is very, very attractive because it's just one place to go to see everything. But what these databases can also do is solve two difficult problems. One is access control. So as I said, the data, I showed in that picture, the data is just lying out on the data lake. Anybody who can access that bucket can see the data. So it's kind of the same problem you have with S3, backups that go to S3. Somebody gets to them, they have your data. So what you need, and in fact, though, when you build applications, you need much more fine-grained control. Databases have this built in. And if the data is lying out in the data lake, for example, on ClickHouse, you get the whole ClickHouse authentication and authority model just kind of pops up and is available to you so that you can control access. The second thing that they do is they help you deal with data changing, which is a really, really big problem. In analytic systems, we tend to have this mythos that you have immutable data. And in fact, my colleague, Josh, who's over here, talked about data which you basically write once and read many times. In fact, in these large data sets, it's write many times and perhaps read it once. Because, if you have to. So, for example, observability data sets. The reason for this is in the underlying storage. We're constantly reorganizing the data as more data arrives to make it more efficient. We also have cases where people will just drop the data for the last day and replace it with a new dump of data. This is a very, very common pattern. Real-time databases can handle this. Data lakes themselves may do this very poorly. So I think we'll see these increasingly coming in. You will have the ability not just to, this will allow us to have some of the capabilities using data lakes that these databases already offer. And in fact, as we go deeper into this is still evolving very quickly, but it's pretty clear that having these databases talk to the shared data doesn't just enable them to collaborate with other applications. Like your real-time database can now collaborate with Spark, can now collaborate with your data scientists who are using Python. It will enable those databases to themselves adopt new paradigms for processing. This is kind of a complicated illustration, but it describes something that we call the food truck model of computing. where what we're doing here in imagining is that we take the basic functions of an analytic database, which are to ingest data, to merge data, to compact it down to more efficient parts, to transform it, like to downsample it, for example, and to query it. And we're going to split them out and run them separately. So what you see now is we can do this already with, to a certain extent, with ClickHouse. We can create now new kinds of services which scale independently, work independently from each other, and can meet completely different use cases in ways that don't interfere with each other. This is an extension of the kind of processing model pioneered by Snowflake, where they put all the data on shared object storage, and then they have virtual data warehouses that, that enable different business units to process it. So this same paradigm is going to come to open source and be much more, and be available to everyone. And the reason I know this is we're working on it right now. So I think I'm pretty much at time here. So there's a final development, and I think this is not a development so much as a question. And this is actually something, if you have opinions or understand this, I want to hear them. And the question is, can data lakes, this integration with shared data, or the shared data on object storage, is this a pathway that will permit us to reach an integration between AI and the data and the capabilities of analytic systems? And you can see here this sort of imaginary picture. We have model training. Clearly, that's happening on the data lakes. It's been happening for a decade or more. We have RAG pipelines, which may or may not be pulling from the data lake. They can go directly to databases or other sources. We have event stream processing, things like Kafka, Redpanda, other streams which deliver high volumes of transactions. They can write straight into the data lake. And finally, we have the analytic systems. So is there a way that having these all share, can they collaborate in new ways that reduce the number of complicated pipelines and able to benefit from each other's capabilities and build more capable systems in the future? I think this is a really interesting question. I think there's a lot of confusion right now, it's safe to say, about how capable AI will ultimately be and what business purposes will be the best. But if this integration can somehow help us to find out what those applications are, I think it'd be very beneficial. So, summing up, open source. Well, data lakes are built on open source. Everything I've described here, Iceberg, Delta Lake, PyArrow, which is used to read Parquet files. S3, of course, is a service from Amazon, but there's a huge amount of open source software that enables access to these systems and to build them in the first place. So open source is going to be key here. A lot of the innovation is being expressed in open source projects. So the data lakes give you this shared access to a single copy of data. That's what allows you then to combine these different technologies in interesting ways. Iceberg and Parquet right now look like winners. If you're making choices, those are probably like buy an IBM. There's kind of the closest thing to a safe bet. I mean, you might check in every now and then because it may change, but that looks pretty good. These managed data lake services are something you'll want to look like. Thank you. What we saw with Kubernetes was as people began to use Kubernetes, of course, the cloud vendors like Amazon stepped up and offered managed Kubernetes, and now most people who run Kubernetes in the cloud use one of those. They don't run it themselves. Same thing is happening with data lakes and will become pervasive in the future. And then these open source analytic databases, particularly the real-time databases, are going to add additional capabilities of being able to answer questions in seconds or less, and they will also help us address hard problems in data lake of compaction and dealing with mutable data. And yeah, is there a unified field for AI and analytics? That's an outstanding question. I'd love to hear your opinions. So thank you very much.